The last thing we need to do is set the integrals of the peaks in our spectrum. And this allows us to determine how many protons are making up each one of those peaks. And so we need to use the integrate icon at the top, and you click on that and it opens up a whole slew of new icons that we can use for this integration process. Now, just like with the peak picking, the spectrometer tries to integrate the peaks. And sometimes it does an okay job, sometimes it doesn't. But often you're just going to want to start over from scratch. And so the way you do that is to click on this icon. It says select to deselect all regions. So click it, and that puts these little green um, boxes underneath the integrals to show that they've been selected. And then we're going to delete those integrals by clicking on this icon with the red X. All right, so we've erased all the integrals and we're kind of back to square one here. So the way I suggest doing this is to zoom in somewhat close on the peaks that you're interested in. So we'll start with these two. And you click on this icon, which says define new region using cursor. And that shows up yellow. All right, so with that icon being yellow, you're going to select each of these peaks in the same way that you would zoom in on those peaks. So find a flat part of the baseline, left click, hold the mouse button, drag it across the peak, and let go. And that sets the integral for that peak. Okay, so left click, drag, let go. All right, now I'm going to move down. So I'm going to click up here, hold the left mouse button down, and drag my mouse over to the next peak of interest. All right, this is our solvent peak, the HOD peak, so we're not going to integrate that. It's not part of our molecule. So this one, left click, drag, and now you see that there's kind of a little impurity peak in the way. There's this little tiny peak that's kind of preventing me from picking that peak cleanly. I either have to click here, which would cut off a little bit of the area of the peak I'm interested in, or I have to click over here, which would include that little impurity peak, that little peak right there. So either way works, you just have to recognize kind of what you've done to that peak. So I'm just gonna select this spot right here to set my integral. All right, and there's one more peak I'm interested in. It's this one. So left click, drag, let go. All right, so you've got all your integrals selected. And so I'm gonna uncheck this icon or deselect it so it's no longer yellow. And I'm gonna zoom back out so I can see kind of everything here. So there's 4 peaks in this particular compound, and right now the spectrometer gave them a 1 to 1 to 1 to 4.8, so maybe that's 5, maybe that's 4.5, we don't really know, but we'll deal with that later. So 1 to 1 to 1 to 5-ish. But the spectrometer does not know the structure of this compound. It's just setting the ratios of the peaks. And the first integral that you select will always be set to 1. But that might not be correct for your structure. And so you have to do some thinking about the possible molecules you're making. So if you predicted a particular major product, then think about, for example, what group of protons in that predicted product would this peak represent? Okay, so for example, peaks that show up kind of in this 6.5 to 9.5 region down in this part of the spectrum are often protons on aromatic rings, like benzene rings. Okay. So if your predicted product had some type of aromatic ring like that in it, you could then think about, okay, I've got 2 peaks in this area, so how many total protons do I have on that aromatic ring? In this case, it's 2, but maybe that's not the right answer. If it's not the right answer for your particular compound, you can right-click on an integral, calibrate it, and change that number to what you think it is. So if you think there should be maybe 4 total protons on that aromatic ring, you could make this one 2. So now it's 2 and 2. If you think there's 6 total protons, you can change this to 3 and make it 3 and 3. And that process changes the integrals of all the peaks in the spectrum. It's just a ratio. But you have to define the number of protons for one peak so that the ratio is appropriate. So again, right click, calibrate, and then put in a value you think is appropriate. In some cases, the integral value is not going to be perfect. And part of that has to do with the fact that there might be some little impurity peaks present. So in this case, it doesn't look like there is, but maybe there's a little peak kind of right underneath this other peak. And that will sometimes mess with the integral ratio. And you just have to use some critical thinking and problem solving skills to figure that kind of stuff out. So that comes with practice, but you can also kind of rationalize your way through it. Especially since you probably have some idea about what product you're trying to make. So if this happens to be off by a little bit, you can rationalize, oh, there's a little peak underneath there or something, or maybe some of these other peaks have impurity peaks that are throwing their ratios off. It can still come up with a decent structure. All right, so again, make sure you save this. And then again, this backs us out of that particular integration processing menu. You'll notice that none of the integrals are showing up here. That's fine. You've saved it, they're in memory, and when we plot the spectrum out, we'll be sure that they show up. So that's how you integrate the spectrum.